Okay, part two, everything's gone, good. Okay, so part one introduced the foot, the Egyptian raw cubit and the metre. For more info and some other connections, check out Alan Greene's channel, the Shakespearean equation of a barcode. I'll put some links in the description. But we began with the origins of the 1 second clock, which is based on a pendulum, and that was at 0.9943 metres or 994.3 millimetres. However, the modern metre we have now is based on the speed of light per second, and so second and metre, okay, there's a nice connection there. But the 30-degree angle of a pendulum is the maximum, because after that it changes, and so you're not getting the 86,400 seconds per day that you want. But that section of arc works out at one speed of light metre is 1 Egyptian raw cubit. So Egyptian raw cubit and the metre are connected by time. But how does a foot connect? Well, okay, 6 raw cubit plus metre is 5 feet, with again splitting hairs difference. Foot cubit plus the metre equals 6 foot, 5 plus 6. Now this will connect to other civilizations, such as we have Egypt over here, but what about the Indus, the Sumerian, or also what's called the Saxon foot? So firstly, let's still consider this. So we have 1 second pendulum, 994.3 millimetres, and we have the speed of light metre, which is equals 1 exactly by definition. Well, how does the foot and the Egyptian raw cubit connect? So firstly, man is a measure of all things. From the tip of your finger to your elbow was the ideal measure of what an Egyptian raw cubit was, but we have surviving cubit rods, and they're also able to measure the Great Pyramids. Okay, so let's firstly introduce the pyramids. Pi over 6 metres or 1 Egyptian raw cubit. So if you were to do the Great Pyramid, now all the pyramids are built on this same unit of cubits, and so the Great Pyramid is 440 Egyptian raw cubits at the base and 280 Egyptian raw cubits high. Now the base has slight variation, so I'll just be using idealised simple measures, but the pyramids, this is the unit of measure that they use. Now the older pictures of it and descriptions will have from the tip of your elbow to the tip of your finger is 1 Egyptian raw cubit. Well, that works out pi over 6 metres. But they also divided it up into units of 7. And so 4 fingers, that would make a palm. So 4 fingers, 1, 2, 3, 4, 5, 6, 7, or 28 fingers in total. And just as a reminder, your pinky fingernail should be 1 centimetre, and the width of your thumb should be 1 inch. So you have a nice connection. But what I mean by that is, so from the tip of your finger to your wrist is 3 palm. Is that in camera? Okay, well anyway, 3 palm. And then we have 4 palm from your wrist to your elbow. Okay, so this distance is 0.299199 metres. 4/7 of an Egyptian raw cubit is there. But what is 1 foot? 1 foot is 0.3408 metres. Now, if we go over here, so 0.304 metres is a foot, and 4/7 of an Egyptian raw cubit is 0.2991999 metres. Very small difference, and the small difference is 5.6 millimetres, just over half of a centimetre. Okay, well let's just do that here. 1,000 millimetres, that's 1 metre, minus 994.3 millimetres. 994.3 is will actually stand a little bit more. 5.7 millimeters, and this will actually, there's a, that will be 5.38 or something like that. But okay, it actually works out to be just over. The actual number is 5.601 millimeters when you do the full Metre conversion. 5.6 minus a metre equals this pendulum, which defines the second. That difference comes from the cubit and the foot. We get the cubit from the 30-degree pendulum and the metre. There we have our first connection. Now it's worth pointing out, so you have Euler's, which is a very important constant. E is 2.718. E minus 1 is 1.718. Now there's a whole stuff I could go into there because it's really, there's some, the way they do the math, it's sort of +1, but 1.718. There are 1.71799 feet per Egyptian royal cubit. The difference again is less than a hair between E minus 1 and the foot and the Egyptian royal cubit. The Egyptian royal cubit to the metre is at a pi/6 ratio. So E and pi are these very important constants. Now, what else is, well, there's another important constant, and that is phi, the golden number. 15 degrees, you can do it in radian, okay, but what's the length of this arc? So we're using the speed of light meter, which defines the Egyptian royal cubit. The length of this arc is pi/6 minus 2, which is 0.261799 meters. Phi plus 1 equals phi squared equals 2.618033. Again, splitting hairs between phi squared over 10, phi squared over 10 meters. If I extended this angle to 15.002, I would get exactly phi squared over 10 meters. There are other connects throughout the pyramids. Phi, pi, and Euler's and these other math constants are in there. But it's, again, emerging from this 1 second pendulum meter relationship. Okay, so the difference between 4/7 of an Egyptian royal cubit, so the length of your forearm, the difference from an English foot is the difference from the Mersenne, Talleyrand, Jefferson second pendulum from the metre, which is defined by the speed of light. This metre, which is defined by the speed of light, creates an arc of pi/6 meters, which is exactly 1 Egyptian royal cubit. So the metre, Egyptian royal cubit, and the foot, the metre, and the second pendulum are very, very nicely connected. Still a lot more to come. Okay, and man is the measure of all things, but just touching on it, we haven't really got anywhere yet. Okay, the next part will be a continuation.